Hello children, welcome to chemistry class. Chapter Chemical Effects of Electric Current. Now, our day-to-day life mainly depends on chemistry. Without chemistry, we cannot think of our daily life. Many phenomena decide our day-to-day life, especially the chemical phenomena. Today, we shall discuss one of the phenomena, that is chemical effect of electricity. First, we shall try to know the meaning. Already we know what is electric charge. We discussed. Now today, we shall try to find the meaning of electric current. What is electric current? Electric current is a stream of charged particles, such as electrons or ions, moving through an electrical conductor. Look at this circuit diagram, how the electrons move. So therefore here, the movement of electrons from one end to another, from higher potential to lower potential, decides the electric current. Okay. With respect to electric current, we can classify the materials, the substances into two major types. The first one, good conductors and poor conductors. Which one we say good conductors? The materials which allow electric current to pass through them are called good conductors. With respect to electricity, the substances which allow electric current to pass through them are called conductors. The well-known examples are silver, copper, gold, aluminium, iron, steel, brass, bronze, and so on. Okay, then what are poor conductors? The materials which do not allow electric current to pass through them easily are called poor conductors. In some references, even we find insulators, but the suitable term is a poor conductor. Why? That we will discuss later. Instead of insulator, it is better we shall use the term poor conductors only. Examples rubber, plastic, wood, and so on. Look at these images. Hence, children, based on electric current, the substances can be classified into two major types: good conductors, which allow electric current to pass through them, and poor conductors, which do not. Okay, now just look at this GIF diagram, pictorial representation, how the conductivity takes place. Wood, here now copper, the bulb glows, means it indicates copper is a good conductor. When glass, no glowing. Steel, the bulb glows. Wood, bulb is not glowing. That means just you observe that one. When copper, we find in the circuit, the bulb glows. If it is glass, the bulb does not. If it is steel, the bulb glows. If it is wood, the bulb does not. So therefore here, this clearly tells us there are two types of substances. Some conduct electricity, some do not. The substances which conduct electricity, we say good conductors, which do not, we say poor conductors. Okay. Then how can one test that a given substance is a good conductor or poor conductor? Very simple. by the use of a conduction tester. So children, this is the best tool, a device to test whether the substance can conduct electricity or not. Hence, how can one test that a given substance is a good conductor or poor conductor with the help of a device called conduction tester. Now we shall try to define what is a conduction tester. A device designed to test the presence of electrical conditions. What is that electrical conditions? Presence and absence of electric current. A device designed to test the presence of electrical conditions in an electrical circuits is called a tester. Look at these two figures. Here, the connections are properly done. The two wires are connected to in that screwdriver to the metallic end. Therefore, the bulb glows. Therefore, here the circuit is completed one. It indicates this one. This is a conductor. Whereas here, one end of that wire is connected to insulating substance, that is a poor conductor. Therefore, the bulb is not glowing. So like this children, what is a tester means? A device designed means arranged like that using torch bulb cell like that the given material. So now here we are testing. See this one, this yellowish one. Okay, here it is connected. Therefore, when this is connected to the circuit, the bulb is not glowing. This means that it is an insulator or poor conductor. Whereas here, this metallic end indicates it is a conductor. So like that, using electrical conduction, that means here using tester, we will be able to identify whether the given material is a conductor or not. There are different ways for what to make a tester. How can different testers be made? Here I have listed out three main one. The first one, testers can be made by constructing an electrical circuit. Just now we have seen that itself using a bulb, wires and cells as shown in the figure. Just here you see already what we have seen in the previous, the same thing. So here the complete this arrangement indicates what a tester. Here when the bulb glows, what happens? This is what a conductor. Hence children, how can different testers be made? One among them is this. Testers can be made by constructing an electrical circuit. The complete circuit itself is a tester. Here, what is that circuit? Bulb, cell and wires are connected to the given substance to be checked. So when they are connected like this, if the bulb glows, what happen? What it indicates means the given substance is a conductor. If not, then if the bulb does not glow means what? Here it is not a conductor, it is an insulator or we say poor conductor. So this is one way of making tester. Now let us take one more. Okay, here the flow of, okay, first children, just here I'm going to brief out some important points. Look at this one. Magnetic compass. This magnetic compass deflects only in the presence of another magnetic field. If we bring a magnet, means now this magnet causes a magnetic field, then we find deflection of this magnetic needle. Magnetic needle means that magnetic compass deflects, shows deflection in presence of another magnetic field. Now, by using this effect, we can make what? A tester. Now come over here. Look at this. Simply an empty matchbox. Inside that, this magnetic compass is placed here, and then wire is wound on that, connected to the cell, or we could say battery. Here two free ends are there. Now the tester is ready. Okay, children. Now what happens whenever electric current flows through the conductor, it produces magnetic effect. Know that once again in detail you will study in your higher classes, but now try to understand. Whenever electric current flows through, whenever electric current flows through the circuit, what happens? It produces magnetic field. In presence of magnetic field, we know what magnetic compass, that means the magnetic needle deflects. Okay, children. Now here also, if we dip this, or if these two ends are connected to the given material, if we find deflection in this magnetic compass, it shows the given substance is what? A conductor. If not, if no deflection, because we know the magnetic needle or the magnetic compass deflects only in the presence of another magnetic field. We know what? Whenever electric current flows through the conductor, it produces magnetic field. Okay, children. That means here the main thing, we don't have any permanent magnet, but simply we are passing electric current. By that, if it deflects, means it is a conductor. Now come over here. The flow of electric current through a material can also be checked by deflection of needle of magnetic compass. So in that magnetic compass, we have that magnetic needle. If it deflects, that shows what? The given material is a conductor. This is another way of constructing a tester. So we have seen the first one, what? Look at, by using the circuits. Now another way of making one more is using LED. It is very a common one nowadays, light emitting diode. In place of magnetic compass, even we can what? Fix these LEDs, because even if the current is very weak also, we find what? The glowing of which one? LED. That glow of LED indicates what? The presence of electric current. Hence, now we are very clear. Testers can be made in three possible ways: by using a torch bulb, by using magnetic compass, or even we could use which one? LED, light emitting diode. Okay. Now therefore the testers are ready. Now we shall come to today's topic, that is conduction of electricity in liquids. What is conductivity of liquid? The conductivity of liquid is a measure of charge. Here the conductivity means through the liquid, what? The flow of electric current. The conductivity of liquid is a measure of charged particles called ions that are free to move around. Just now look at this figure, image. See that movement of ions. So therefore, some salts, if we take common salt, copper sulfate, in their crystal form, when they are in solid form, they do not conduct electricity. But in aqueous form, because of the formation of ions, they become what? Conductors. This is what given here. Look at, the conductivity of liquid is a measure of charged particles called ions that are free to move around. Just you observe how the ions are moving. Okay, this is what we mean conductivity of liquid. How can we check whether the tester is working or not? In case of liquid, okay, in the beginning, just we used to test what the solid conductors. Now, in case of liquids, okay, here, how can we check whether the tester is working or not? Very simple, children. Join the free ends of the tester. Look at here, just it is an example, that's all. If these two ends are joined, then what happens? For a moment, just for a moment, and check whether the bulb glows here. If the bulb glows, when we join these two ends, if the bulb glows, it means tester is working, and if not, it means the tester is not working. In case if does not glow, that means if the bulb does not glow, check that all the connections are tight or not. So this is how. After that, then we can use for to test the conductivity of liquids. Okay. Do all liquids conduct electricity? Do all liquids conduct electricity? Conduction of liquids depends on the ability of liquids to form ions. Only those liquids which have the ability of forming what? Ions only can conduct electricity. That's what given. Once again, look at the question. Do all liquids conduct electricity? Conduction of liquids depends on the ability of liquids to form ions. Some liquids, such as oil or alcohol, do not form ions. Hence, naturally, they cannot conduct what? Electricity. Vinegar. Just here I have given one example. Vinegar, we know acid is mostly water with a small amount of acetic acid in it. So therefore, acetic, the diluted acetic acid, we say vinegar. The acetic acid separates into ions in water. Hence, it is a solution. Therefore, its solution conduct what? Electricity. Conduction of tap water depends on its hardness. Therefore, here even tap water, that conductivity depends on its hardness. You know, hard water, that chemistry and all. Hence, children, here the question is this: do all liquids conduct electricity? Means no. Answer is what? No. Based on some conditions only. That means those liquids which are capable of producing ions in their aqueous form or in the molten form only can conduct electricity. Just look at here, I have given that tap water, and here we find a small deflection in this magnetic compass. Magnetic needle deflects. This shows what? Tap water is what? A conductor. How can we check that liquids conduct electricity or not? Immerse the two free ends of the wires into a beaker containing water or any liquid without touching each other. Just here we have seen now. Look at this. These two ends. Okay, children, now the tester is ready. These two free ends we have to dip into the given liquid. It may be a tap water or any liquid which we have to test. Okay, though the free ends of the tester should be immersed in the given. Immerse the two free ends of the wires into a beaker containing water or any liquid without touching each other. If the bulb, okay, torch bulb it may be, or LED glows, or magnetic compass, what we have seen is a magnetic compass. That magnetic compass needle deflects, the liquid conducts electricity. Very simple test. If not, the liquid does not conduct electricity. If the brightness of the LED glow is high, then those liquids are good conductors. Hence, how can we check that liquids what conduct electricity or not? Means very simple, using that tester circuits can be checked. Now let us take one simple activity. Describe an activity to show the lemon juice or vinegar conducts electricity. Pour 1 teaspoon of lemon juice or vinegar in a small. If you are given lemon juice or if it is vinegar or any other, here just these two are examples, that's all. In a small plastic or rubber cap. Simple activities can be done, okay, in the classroom and all. Bring your tester. This is the tester. The two free ends here, magnetic compass and the cell or battery, okay, that completes the tester. In place of magnetic compass, even we can have what, LED or torch bulb. Look at children once again. Bring your tester over this cap. Here this cap, that means this container has the given liquid. Here the given liquid is lemon juice or maybe vinegar, and the ends of the tester dip into the lemon juice like this. Look at here, dipped into what, the lemon juice or the vinegar. The bulb glows, indicating here, instead of bulb we have here what, magnetic compass needle. If it deflects, that indicates what, lemon juice or vinegar is the conductor of electricity. Here we find, in reality, when we conduct the experiment, we see that what, the bulb glows, LED glows, or even magnetic compass deflects. Hence no doubt at all what, lemon juice or vinegar, these are good conductor of electricity. Now any liquid children, if we are given, this simple tester is enough. In place of lemon juice, we have to go on changing the given liquid which is to be tested. Okay, I hope it is clear. Why is it preferable to classify materials as good conductors and poor conductors instead of classifying as conductors and insulators? In the beginning only I told you, know, actually it is better to say what, poor conductor instead of insulators. Why? Means, for example, if you take copper sulfate in solid form, it does not, but when it is in the aqueous form, it conducts. That's why under certain conditions, most materials can conduct electricity. So therefore, they need some special conditions. If the conditions are provided, then they become what, conductor. That's why we cannot say they are permanently insulators. Instead of saying insulators, poor conductors. Poor conductors means the degree of conductivity is very least, okay, like that. That is why, once again, actually under certain conditions, most materials can conduct electricity. That is why it is preferable to classify materials as good conductors and poor conductors instead of classifying as conductors and insulators. Distilled water, for example, we know does not conduct electricity. But when salt is dissolved in distilled water, we obtain salt solution. This is a conductor of electricity. That's why instead of saying insulator, it is better to say what? Poor conductor. Distilled water is a poor conductor of electricity. It will become conductor. It will show conductivity if what, when salt is added to it. Hence it is better to say what, instead of what, insulator, let us say as what, poor conductor. Test the conduction of electricity through the following liquids and state whether they are good or poor conducting liquids. Okay, here I have given some liquids, lemon juice, vinegar, tap water, vegetable oil, milk, honey, soda, distilled water, kerosene oil, curd and water, and so on. So by using that tester, maybe torch bulb or what, that magnetic compass, or even we can use which one, LED. By using that arrangement, okay, children, if we take in that container lemon juice or vinegar, if the magnetic compass deflects, then we say it is a conductor. If not, it is not a conductor. So just like an activity, let us try. Okay, even you can try at home. Now here, look at this vinegar. Okay, just what we have to do in place of vinegar, first you place lemon juice, next vinegar, tap water, vegetable oil, milk, like that. Each time observe the deflection in the magnetic compass, that means the needle. If the needle in the magnetic compass deflects, then the given what, the solution or the given liquid is a conductor. If not, it is a poor conductor. Okay, children. So now, after conducting, you will find this result. Okay, let us take in general. Here I have given one more diagram. Generally, solution. If maybe in place of magnetic compass, we may have what? Electric bulb. Okay, children. The solution. Anything. It can be curd and water, kerosene oil, water, vegetable oil, milk, honey, soda, distilled, tap water, vinegar, or lemon juice. Here, this is the result. When in the container, if lemon juice is taken, we find the compass needle shows deflection. Okay, children. If shows yes, it shows deflection. That yes, yes means what? It is a good conductor. Vinegar, deflection, yes, good conductor. Tap water, deflection, yes, due to the presence of some minerals, salts, etc. That's why tap water shows the deflection, that magnetic needle deflects. Hence, yes, good conductor. Vegetable oil, no. That chemistry of vegetable oil, etc. You will study in organic chemistry later. Milk, yes, due to the presence of some acid, lactic acid, like that. Good conductor. Honey, no. What is the chemistry? Try. Poor conductor. Soda, yes. Good conductor. Why? Just okay. Wait. In your higher classes, you will study the chemistry of all this. Distilled water, no. Just now we have discussed no, no, because no mineral salts, nothing. Purely H2O, no. Poor conductor. Kerosene oil, no. Why? What is the chemistry? Again, you wait. But here, simply, we are asked to check whether they are good conductor or poor conductor by using the suitable testers by conducting experiment. After that, we can list out like this. Kerosene oil, no, poor conductor. Curd and water, yes, good conductor. Thus, children, in today's lesson, the main aspects is what? Here, by using tester, we can check the conductivity in liquids. If the bulb glows, or if the LED glows, or if the magnetic needle in the magnetic compass deflects, they are good conductors. If not, they are poor conductors. And application of chemical effect of electric current, that we will discuss in the next class. Thank you, children.